Chemical equilibrium. A quick note. During a reversible chemical process, chemical equilibrium is the state in which there is no net change in the quantity of reactants or products. When a chemical reaction is reversible, the products react with the original reactants as soon as they are created. There is no net change in the quantity of the chemicals involved when the two opposing reactions are in equilibrium because they are occurring at identical rates, or velocities. At this point, the reaction may be deemed to be finished, meaning that the maximum amount of reactants to products has been converted under the given reaction conditions. There is no net change in the amounts of the substances involved when the two opposing reactions are in equilibrium because they are occurring at equal rates, or velocities. At this point, the reaction may be deemed to be finished, meaning that the maximum amount of reactants to products has been converted under the given reaction conditions. Why is dynamic equilibrium referred to as chemical equilibrium? An equilibrium stage is the one where the forward reaction rate and the backward reaction rate are equal. The number of reactant molecules turning into products and product molecules turning into reactants are equal at this point. Chemical equilibrium is dynamic because it can occur anywhere, under identical conditions, with the same reactants and continuous molecule exchange. Factors affecting chemical equilibrium. Le Chatelier's principle states that if any of the variables influencing the equilibrium conditions change, the system will offset or lessen the impact of the overall transformation. Equilibrium in both chemical and physical systems is governed by this principle. The equilibrium of a system is influenced by a number of variables, including temperature, pressure, and the system's concentration. The following section discusses some crucial elements that affect chemical equilibrium. Change in concentration. The reaction that consumes the substance added reduces the concentration of the reactants or products added. The reaction that is in the direction that replenishes the substance that is removed relieves the concentration of reactants or products removed. In a chemical equilibrium, the composition of the mixture changes when the reactant or product concentration is altered. An exothermic reaction's equilibrium constant decreases with rising temperature. The equilibrium constant in an endothermic reaction rises as the temperature rises. The temperature change affects both the equilibrium constant and the rate of reaction. According to Le Chatelier's principle, for exothermic reactions, the equilibrium shifts towards the reactant side as the temperature rises. However, for endothermic reactions, the equilibrium shifts towards the product side as the temperature rises. Catalyst effect. A catalyst has no impact on the chemical equilibrium. It just quickens a response. In actuality, a catalyst quickens both the forward and the backward reaction. As a result, the reaction reaches equilibrium more quickly. In a catalyzed or non-catalyzed reaction, the same amount of reactants and products will be present at equilibrium. Only a lower energy transition state of reactants to products is made possible by the presence of a catalyst in a reaction. Effect of adding an inert gas. When an inert gas, such as argon, is added to a fixed volume, it has no effect on the reaction and does not disturb the equilibrium. The reaction quotient will change if the gas added is a reactant or product in the reaction.